Hello and welcome to the second part of the Asteroids tutorial in Godot Engine. So where we left off in the previous video, we had created a quite simple simulation where we had two asteroids that would fly around in space, collide with each other, and then wrap around the screen whenever they came out of view. So in this part we're going to add a spaceship to this demo, so that the player can move around and shoot stuff. So first off, I'm going to create a folder here to keep all of my assets structured. So I'm going to create a new folder and call it ship. And this is where we'll put all of our spaceship assets. Next I'm going to go into my asset folder and import a ship.png. Then I can drag it into the scene. And first you'll see that this is very large, so I'm going to scale down a little bit to something like 30%. That looks good. And then I'm going to center it. So it's up here. Next I'm going to go under game and create a rigid body. A rigid body 2D and not the regular rigid body, it's important. And then I'm going to name this ship. I can drag the sprite in here and rename that sprite. So in all of my entities I have called the sprite to simply sprite and the collider to collider. And that is so that I can share scripts between them and don't have to know about the naming. So next I'm going to add a collider. So when we created the asteroid here, we approximated the shape as a circle, and that worked in that case, but the ship, as you can see, is quite complex with a number of parts sticking out. So in this case I'm going to use a polygon collider. So we add and then create a collision polygon 2D instead of collision shape. And then we can name it collider. And then I can press this little icon up here with a square and a plus on it to start creating my polygon. So then I can just press here and add points. Like so. You can see that Godot automatically turns this into a number of different polygons, and the reason for that is that it's very expensive to compute collisions with convex shapes with parts sticking in like this. So most game engines will automatically turn the complex polygon into a number of simple ones, because that's cheaper for performance. So now when we have created this, we can go up on our ship and we can configure how it will interact with the physical world. So first, you remember that we always set the gravity scale to 0, to avoid it to start falling down as soon as we start the game. We can also reduce the mass a little bit to something like 0.5, so that the ship weighs about half of what the asteroids weigh. We can also reduce the friction of it. Like normally in outer space you wouldn't have any friction, but to make it simple for the player to kind of help them along to slow down, we can reduce it to about 20%. So it's one of the cases where this game is not completely realistic, but it's plausible and feels good when you're playing. So when we've set up the rigid body, remember to press this little icon here so we can move them together as a group, and then we can move the ship into the scene. So next we're going to create the script that controls the ship. So I'm going to go down to the bottom here where it says script null, and then I'm going to add a new script. By default, Godot names it ship, which is okay, but I want it to be located in the ship folder so that all the assets of the ship are in the same folder. So I'm moving it there, saving it, and then we can create it. So the first thing we need to do here is that the ship needs two different parameters to control how we're moving it. We need to know how fast the engine can accelerate in a forward direction and how fast we can rotate around. And these are two parameters that we are probably going to want to tweak a little bit. So we're going to create an export variable for those. We say export, and they are of the type float, var engine thrust. And by default we can set it to 200. And next we can create an export float var spin thrust, and we set it to default of 2000, a little bit larger. So this will allow us to, if we select the ship in the GUI here and go to the top, we will have two different parameters here that we can control, and we can increase and decrease and so on. So now that we have created these parameters, we need to store the current thrust and the current rotation of the ship to know how much forces were applied to the ship. So let's create a temporary variable here called thrust. And by default we set it to an empty vector 2. And then we create a new variable called rotation dir, and we set it to 0 by default. So these will control how much thrust we currently are applying to the ship, and what kind of rotation we're currently applying to the direction. Then these two variables need to be controlled by user input. So we're going to go down here and remove the comments from this function. We can remove these comments as well, and then we check for user input. So all the user input is located in a class called input. And in there we have a method called isActionPressed. This will check every turn if that particular key binding is currently pressed. And there is a key binding that exists by default that's called UI up. So we're going to check if the up key is pressed, and if so, we set the thrust to a vector 2 with the x direction of engine thrust and the y direction of 0. So this will be a vector that is always pointing to the right with the same length as the engine thrust. And if the key is not pressed, we set it to 0. So vector 2. So now we will always know by just checking this variable if the user is thrusting forward or not. Next we can do the same thing with the rotation. So we check if input is action pressed with a UI left. And in that case we want to start spinning counterclockwise towards the left. So we say rotation dir equals -1. If the left key is not pressed but the right key is pressed, we can take an else if input is action pressed UI right. In that case we want to rotate clockwise, so we say rotation dir equals 1. So, and if none of these are true, then we want to stop rotating, so we set rotation dir to 0. So now we have set up these two variables so that they will always have the correct value depending on what the user is pressing. But we still haven't applied any kind of forces to the entity. And if you remember in the previous video I told you that forces always need to be applied in a certain method. They can't be applied in the process stage, because that would be in conflict with the physics system. So down here we create a new function called integrate forces. And that's the function where we always put our physical calculations. And then we say set applied force to apply a force to the ship. And we apply the force that is the thrust vector. But the thrust vector is always rotated towards the right. So we need to rotate it to our current direction. So we do that by calling rotated and then our rotation. And rotation is a variable that is always available if you extend a rigid body. Next, we're going to set applied. And the force here is always a linear force. It's something that's pushing in a certain direction. But when we spin, we don't want to apply a force in a direction. We want the force to rotate us. And that is called, in physics, a torque. So we set applied torque, and we set it to the rotation there, and then we multiply that, we scale it by the spin thrust, so the parameter that we can configure. So in that way, we will spin faster, depending on how large this number is. So let's try it. We can move around. You see that I can spin in different direction, and I have a very small friction. I can also bounce towards the asteroids because we have a collider. So you remember in the previous video that we added some logic to this Asteroids class that would make it so that it wraps around the screen whenever we move out of view. That is great, but we want the same kind of behavior in the ship as well. So we could potentially just take this piece of code and just copy it into the integrated forces method of the ship. But that would mean that we have code duplicated in two different places, and that's kind of a mess to maintain. So what you normally do in programming is that you would share code between these two classes. So we can do that by introducing inheritance into this very simple object system. So asteroids and ships both share the behavior that they are entities in a weightless state in this universe. So let's create a class called weightless that both of them can inherit from. So we're going to go under File and select New. Then I'm going to create a folder called weightless. And here I'm going to create a weightless.gd. And I'm going to make it so that it inherits from rigid body 2D, since we still want all of those member variables to be present. So we create it, and then here we can copy paste the logic from the Asteroids class here. So we take these two, put it into weightless, and then I'm taking the wrapping around logic and putting it there as well. We don't need a ready method. So like so. Next I can go into the Asteroid class, and I can say that this extends from, instead of rigid body, we extend from res. That is how you mention things on the resource path. Weightless, and then weightless.gd. And then I can remove this method, because this is already done in the weightless class. So we remove that, and we can remove these two as well, because they're also present in the parent class. Next we go to the ship. We can copy this, and then put it up here. But here we have a problem, because the ship already implements the integrate forces. So this would override the behavior of the parent. So whenever the integrate forces function is called here, it will only do these two things, but it won't do all of the things of the wrapping around that is done in the parent. So we need to add a line here. We need to say dot integrate forces. And this is the way to tell Godot that first we want to do these two things, then we want to do all of the things that our parent wants to do. So now we can try it. So if I fly away, you'll see that I wrap around. So let's finish off the ship by right-clicking here and saving it as a subscene. We don't really have a need to instantiate multiple instances of the ship, but it's a good way to keep things organized, to always save things that are used independently as their own subscenes. So I saved this as ship, and now we can see that all of these are managed by their own scenes. So just flying around in space, it's a little bit fun, but it's not really what this game is about. In Asteroids you want to blow things up, so we're going to add some missiles into the game. So the same principle as before, we go back here, we create a folder called missile, and we'll go in there, and then I'm going to import the missile asset. So here, and I take this and drag it in there, we can move it into the scene. Then I want to scale it down a bit, move it up to the parent first, and then scale it down, transform, set the scale to something like 0.4 perhaps. This looks okay. Center it, like so. And then I'm going to create a rigid body. Rigid body 2D is important. Call it missile, put the sprite in there, call this sprite. Next I can add a collision shape. In this case it's okay to approximate it again, not with a circle perhaps, but it's almost like a square, so I'm going to use a rectangle shape 2D. We can drag it down a little bit so it fits the missile, like so. And then we can call this collider. We also need to configure the missile so it doesn't start to fall down. So I'm going to set the gravity scale to 0, set the mass to something like 0.1, and take away all the friction. Then we can move it as a group, and then move it down here just so we can try it out. So right now I don't have any particular logic I want to add to the missile, but I'm still going to create a script here just to make sure that we have all the assets created in the correct place. So I'm going to right click here and attach a script, and I'm just going to call this missile, but I'm going to put it in a missile folder. So if we take a look at it, it's okay to have this basic setup right now, because I just want the script as a placeholder. And next I'm going to right click here, and I'm going to save this branch as a scene. Go up, go into the missile folder, and save it there. So let's make it so that we can shoot missiles. We go back into the ship file here, and at first I need to be able to access the missile subscene that we just created to be able to instantiate it. So I go up here and I say var missile equals preload, and that is how you tell Godot that I want to load a particular scene when I'm creating this class. And then we say res missile slash missile.tscn, and that's the file we just created. So now I have this scene here and I can create instances of it. So let's go down, and then in here in the process I'm going to add a new input. Input is action pressed, and I want to use the space key for this, and there is an action already mapped to this, and it's the UI accept. So we take that, and then in here we can create the missile. So we say var missile equals missile instantiate. So this will create a new instance of the scene, but it still isn't added to the scene. We have created the instance, but it's just floating around in memory. It's not present in the view. So to add it, we need to use the add child method. But we don't want to add it ourselves, because that would make all the missiles move as we are moving, and that's not realistic. So we want to add it to our own parents. So we take get parents, add child, missile. So now we have added the missile to the scene, but it will be added at the location of the missile scene. And currently it's somewhere here where we had the entity when we created the subscene. So to be able to instantiate it at our own position, I'm going to go under the ship again, and I'm going to set the missile position equals position. So this is the position of ourselves, and that's available since we're extending weightless, that is in turn extending rigid body. And we set the position of the missile to our own position. We want to do the same thing with the rotation. So set the rotation of the missile to our rotation. And then if you know your physics, you know that if you're in a moving car and you throw something out of the window, that thing will initially move with the same speed as you do. So we also want to copy over the velocity. To say missile linear velocity equals our own linear velocity. So that would make it so that the missile moves with the exact same speed as we do. But we do want it to move a little bit faster, because we want it to move away from ourselves. So to do that, we need to add a parameter. So we go up here, and we say export floats var missile speed. And we can set it to something like 300. So then we can go down here and we can add to the linear velocity a new vector 2 with the length of the missile speed, a 0 as the y coordinate, and then we rotate this with our own rotation. So this is the same principle as down here. We create a vector that has the same length as we wanted to move with, and then we rotate that vector with the rotation that we currently have, and then add it to the linear velocity of ourselves. But if we just play this right now, what is going to happen is that every turn we call this method, and then it checks if the UI accept is pressed. In that case it creates a missile, and then it goes up, and the next frame it's going to do the same thing. So it's going to spawn a lot of different missiles. And we want to limit it a little bit. So let's add some recharge time. So we go up here, and we say that it takes a certain amount of time to recharge the missiles. So we say recharge time. And by default we set it something like 0.2. It takes 0.2 seconds to recharge. And next we need to keep track of how much time has passed since the last recharge. So we say var recharge timer equals 0 by default. By default we can shoot immediately. Then we go down here, we check if recharge timer is less or equal to 0. It means that we can fire. In that case we want to do this. Otherwise, if the timer is more than that, we want to decrease it. So set recharge timer minus equals, and then we want to decrease it with the amount of seconds that has passed since the last frame. And to get an accurate number of that, we're going to use the delta variable here that is always available in the process method. So we decrease it with the delta, and then we need to add one more thing. We need to reset the timer whenever we add the missile. So down here we're going to set the recharge timer to the recharge time, 0.2 seconds. So now we can try it. But you'll see that this is quite strange. It fires missiles and they do seem to have the correct rotation initially, but as soon as they leave us, they kind of start moving around and start turning around. And the reason for that is that they are colliding with us. So we haven't told Godot what entities can collide with which other entities. So all the entities are colliding with each other. So whenever we shoot a missile, the missile starts to flip around. So to fix that, we're going to introduce something called collision layers. So we close this down, go up under project settings, we go down to layer names 2D physics. And this will allow us to name different layers. And by default you see that we have 20 different layers here. So let's use them and start naming them. So the first layer is going to be the asteroid layer. That is where all the asteroids are located. Next I'm going to create a ship layer. That's where our ship is. And then a missile layer. So close this. Next we need to configure what objects are on which layers. So here it's important that we do this on the actual scene and not on the instance. So if we change the missile here, we're only going to affect the one instance that we already have here in the scene. So we need to press this little icon here and get in under the actual subscene. And then we can go down under Physics Body 2D Collision. And then we can set that this is supposed to be on the ship layer, not on the asteroid layer. But the missile can collide with the asteroids and not with other missiles. So this is correct. So that was the layer. The layer tells us which layer we are on, and then the mask tells us what other layers we can collide with. So missiles can't collide with each other, but they can collide with asteroids. So we save this, and then we go back and take the ship, and we say that the ship is on the ship layer, not on the asteroid layer. And the ship can collide with asteroids, but not with other ships and missiles. And then we go back to the game, and we take the asteroid. We go down here, and we say that the asteroid is on the asteroid layer, and it can collide with other asteroids, but it can also collide with ships and missiles. And now if we play the game, you'll see that we can fire and the missiles can collide with asteroids, but not with us. So the last thing I'm going to do in this video is make it so that the missiles come out of the cannons of the ship. So to do that, I'm first going to put the ship on a higher layer so that the missiles are rendered below the ship. So I go under the ship subscene, go down under Z-index, under node 2D, and set the Z-index to 5. So it will make it so that the ship is always rendered on top of the missiles. Next, we're going to go under the ship code. So we're going to make it so that whenever we fire the missiles, 2 different missiles are created. And they are created with a certain offset of our position. So we create a for loop. And here is one of the nice things in Godot scripts. We can actually iterate over a list that we create in place like this. So we say that we want to iterate over every offset in this list. And then we say that first we want a vector 2 with something like 15 pixels to the right. And we have a distance between the cannons of about 45 pixels. So I'm going to take 45 divided by 2. That's the distance from the center that we want it to be in an upwards direction. And then we take minus because we want it to be above the center. Now we do the same thing, but with a positive number on the bottom one. So both missiles are spawned at 15 pixels from the to the right of the center. But the first one is half of 45 pixels up, and the other one is half of 45 pixels down. Then we move this in, and then here we're going to add the offset to our position to make it so that the missile is created a little bit away from our center. But we also need to rotate the offset so that it's affected by the direction of the ship. So we say rotated by rotation. So it's the same principle as down here and down here. We rotate all of the vectors with our rotation to keep it local. So now we can try it. And now we can see that my cannons are firing missiles. That's all for this video. In the next video I'm going to show you how to make things explode. So we're actually going to interact with the entities that are created.